So in example 2, I copied and pasted our strategies from example 1, and you'll notice in green that I added one. Sometimes when we've had to add or multiply or whatever with these rational expressions, we've had to factor first to make our life easier. Now, not all of them. In fact, A and B, we won't have to do in any factoring, but we will have to do some factoring when we get to part C. So I've added that because it's going to be a strategy we're going to use in example 2, and we're going to also use that same thing in example 3. So part A. We have negative 3 over x plus 2. I'm going to leave some space beside that. And 2x over x minus 3. We need to get a common denominator here if we're going to use the same strategy that we did from before. So if we're using the same strategy, what would my common denominator be? X plus 2, and then here I'm missing an x minus 3. So I'd have to multiply top and bottom by x minus 3. And over here, I have the x minus 3, but I'm missing the x plus 2. At this point, we have our common denominator. We need to multiply to get rid of our fractions. What are we going to multiply by? We're going to multiply both sides by x plus 2 and x minus 3. As a result, can you see that this and this would simplify on both sides? If I multiplied both sides by x plus 2 and x minus 3, I would end up with 3 times x minus 3, 2x times x plus 2. Oh yeah, thank you, it's a negative 3. That negative would still be there. I should make that negative more obvious when I wrote it to begin with. And for this reason, there is a strategy that sometimes is taught for a question like this. When a fraction is equal to a fraction, what has happened? Do you notice that this x minus 3 went up and multiplied by that negative 3? And the x plus 2 went to the other side and multiplied by the 2x. We could see that by using the same strategy we've used so far, where we got our common denominator and multiplied to get rid of the fractions. For this case, sometimes you'll hear people talk about, oh, you just need to cross multiply. That's the name of this strategy, where when you have one fraction equal to another fraction, you can multiply across and simplify it. The reason we did the math at the beginning was to explain where it comes from, because there's some controversy. Some math teachers say, I never use the words cross multiply, because students do it when they're not supposed to and they don't understand it, and so I just don't teach it because I'd rather not teach it than have them make mistakes when they don't understand it. But I feel like if we teach what happens and we can see a pattern, it's not bad to use a pattern that we notice. But it is important to understand where it comes from. So in this situation, we could use that strategy of cross multiplying because we can see that, oh, if I got a common denominator, all that's going to happen is the x minus 3 is going to move to the numerator on this side, and the x plus 2 is going to move to the numerator on the other side. And when I simplify and get rid of my denominators, this is what I'm going to get. At this point, if we're going to solve it, oh, we haven't listed all of our non-permissible values. Maybe this would be a good time to do that. Are we dividing ever in this question? Yes. We're dividing by x plus 2. What does that mean? X can't equal negative 2. And here we're dividing by x minus 3. That means x can't equal positive 3. So let's list our non-permissible values. And now we can go about solving this. So let's combine some like terms. So if I distribute, I'm going to get negative 3x plus 9 equals 2x squared plus 4x. It's a quadratic equation. We solve quadratic equations by making one side equal to 0. Two x squared, add 3x to both sides. And now we have to try to factor this. So, if we can factor it, to get 2x squared, it would have to be 2x and x. To get 9 could be 3 and 3 or 9 and 1. Nine and 1. If we try 9 and 1, my outside is 2, my inside is 9. Does that ever make 7? Yes. I would need to have a positive 9 and a minus 1, a quick check, and those all work. So what would x be? Well, here x would be 1. Here x would be negative 9 over 2. Were either of those non-permissible values? No. So it's actually not bad practice to take out, your favorite green pen and put a little check mark underneath, just to show that you have checked them to make sure, because there will be some cases where you will get an answer that's one of your non-permissible values. And then you have to put an X through that to say that that's not possible. All right, part B. Let's start by listing our non-permissible values. It is good practice to do that first. Are we ever dividing? Yes. Or what would make us divide by 0? X can't equal 5. Anything else? X can't equal 1. So 5 and 1 are non-permissible values. So if I got a common denominator, here this side is missing x minus 1, and this side is missing x minus 1, and here this side is missing x minus 5 and x minus 5. Can you see that this would have been a situation where we could have cross-multiplied? And again, that strategy only works if you have a fraction equal to a fraction. So it would have worked here to cross-multiply. Multiply this side out. Multiply this side out. Combine your like terms. You see that your x squareds cancel out. So now how do you solve this if there's no x squared? Just get x by itself. But sometimes that can cause you problems because you're so used to solving harder questions that when the easier question appears, you all of a sudden forget how to do it. Yes. In this case, 8x minus 2. So we can move the 2 over, divide both sides by 8. Simplify our answer. X is equal to 1 over 4. I don't know why it says 1 over 3. I'm checking right now to see if we've made any mistakes. Have we made any mistakes? Should it be negative 3? It should be something in here. This is a mistake right there. What should it be? It should be just 1x, which would make, when we bring this over, 6x, 6x. Does that work out then to be 1/3? Yes, it does. There was our mistake. Okay? Yeah. So easy to make a mental math error throughout it, and then finding it is sometimes more difficult. Okay, there's example, the second one. Let's look at the third one. Because the third one is where the factoring comes in, because we have an x squared minus 9. And this is a great example of, if you cross multiply at the beginning, you will make your life way more difficult than it needs to be. Even though it's a fraction equals a fraction, that shortcut of cross multiplying in this case would make things more difficult. So, why do we factor first? Well, we factor first x plus 3, x minus 3, for a couple of reasons. One is it helps us see what our non-permissible values are. So if we start listing our non-permissible values, we can't necessarily see them all until we've factored completely. What would make us divide by 0 here? X can't equal 3. That one was obvious, but after factoring, we also see that x can't equal negative 3. Now, when looking at what would make us have a common denominator, after factoring, we can see they both have an x minus 3, but the second one is missing an x plus 3. And once we've multiplied, once we have our common denominator, you could now multiply both sides by x plus 3 and x minus 3. If you did that, your denominators would simplify away. And you would get 7x minus 15 equals x minus 2 times x plus 3. Seven x minus 15 equals, multiply this out. Try not to make any mistakes this time. X squared plus x minus 6. What kind of equation is this? Quadratic equation, so we need to make one side equal to 0. Minus 7x on both sides. Add 15 to both sides. X squared minus 6x plus 9. Can we factor this? Well, it would be x and x. 3 and 3, minus and minus. Yes, it works. So we get x equals 3 as a solution. But that was a non-permissible value. So we have to put x's through those. Do we have any solutions left? No. All that work to find out there was no solution. And that's how you would show your work that there's no solution. You would not get full marks for leaving this question blank on a test. Doesn't mean the same thing. You writing no solution at all and the answer being no solution are different things.
Yeah, but like, what if you just see it and you just know, and you just write no solution is the only thing? Is that still?
So it'd be like, no, you have to show all your work. It'd be like me handing back the test, and you say you didn't mark it. Well, it's nothing. That wouldn't be the same. Okay, questions for practice. Try 6 and 7.